Okay, these are a little bit more complex because there's factoring involved, but still pretty easy. We're going to take the derivative of each term. So the derivative of this first term right there, the 3 would get brought down in front, so we'd have negative 15y squared. We're going to tack on that dy dx. The derivative of a constant is 0, so I'm just going to leave that like that. The derivative of x cubed is 3x squared. The derivative of 2y squared would be 4y, and then we're going to tack on that dy dx. All right, well now we need to get the dy dx's by themselves. So the first thing we're going to do is we're going to bring the put the dy dx's on the same side. So we're going to subtract this from both sides. Negative 4y dy dx. And when we do that, in the same step, I'm going to factor out the dy dx. When we factor it out, notice what we have left when we move over there is negative 4y, and then subtract 15y squared. And what we're left with on the right side is 3x squared. Okay, we want to get the dy dx by itself. This whole quantity is attached by multiplication, so we're just going to divide both sides by that quantity. Now at this point, if all 3 of those terms shared something in common, you would go ahead and factor that out. The other thing that you can do is see how they both have negative signs down there? Sometimes professors are going to want to see that you understand we don't really like negative signs in the denominator. Well, a positive divided by negative is negative, so we would just put the negative sign in front of that whole fraction, and it would be simplified like this. Now in CUDA software, they might leave it in like that answer right there. Either way, okay? For each problem, use implicit differentiation to find dy dx at a given point. We're going to do what we just did, and then at the very last, when we find the dy dx, we're going to go ahead and plug that point in, simplify again, and then you're going to have the slope of the tangent line. All right, well, the derivative of a constant is 0. And I should always look to make sure it does say dy dx. The derivative of 4x squared is 8x plus 6y, tack on the dy dx, plus the derivative of 5y is 5, but tack on the dy dx. These are on the same side, so I'm going to subtract that 8x from both sides, and then it'll go away on this side. I'm going to factor out the shared dy dx, which leaves 6y plus 5. That quantity is attached by multiplication, so we're going to divide both sides by that. Now we have dy dx is equal to negative 8x, and instead of x, I'm going to go ahead and put negative 1 over 6. Y, I'm going to put negative 1 plus 5. Well, negative times negative is a positive. Negative 6 plus 5 is negative 1. And when you simplify, there you have it. All right, and I'm going to do one more video on the more complex one.